All right, so we're going to look at our implementation of neural networks. We're going to look at a very tiny example, the one that we worked on in Excel, where we just used the first observation and worked it way into, through the network. Okay, so that data. Okay, so we'll go through the steps, and then we will look at a regular data set with the classification target, and then we look at an interval target. So there are three different things we're going to look at, and we will look at also how to use Caret to go through several parameters in the model. So we're going to use two libraries for neural network. One is called neural net, and another one is called NNet. So those are the two that Caret supports. Okay, so we'll start with these two libraries. And one thing that we need to keep in mind is this pre-processing. Okay. Neural networks perform best when your predictor variables are in the range of 0 to 1. Okay. Now, if you have a factor variable, okay, so the factor variable should be converted into dummy variables, zeros and ones. Okay. And if you have numerical variables, then they should be normalized with range normalization. Range normalization will normalize the data within the range of 0 to 1. Okay. Very important. So remember, all numerical variables should be range normalized. Factor variables must be converted into dummy variables. Factor variables, after converting into dummy variables, don't normalize that. Okay. So, I mean, even if you normalize that, it will still be 0 and 1 anyway. But, okay, so that's the overall general concept. Okay. So let's start with bringing in our tiny data. Okay, so the one that we looked at in Excel file. So we bring in, let's call it tiny df. Okay, so we have 6 observations. These two are the predictors, and acceptance is our target. Okay, so it's a small data set, so we're not going to partition this. So we'll just use the whole thing. And first, let's look at the neural net library. So library neural net. Okay, so neural net is not there. So neural net. Okay, so then neural net. Okay. So in neural net, we have the neural net method. So here we can have, there are several parameters that we can set, and the most important one is, of course, a couple of them, hidden and learning rate. Okay, so if you say neural net, right, then the target. Okay. Now target has two values, right? So acceptance has two values. So we have to specify which value we want to use. So say like, and we want the neural net to be built with that as our output layer node. Okay. And then say we want salt and fat. These are the two predictors that we want to use. Okay. And data equal to tiny df. Okay. All right. So if you don't give any other parameters, so the default will be used. Default here is hidden is 1. Okay. So now let's X that out, and we can do a plot of that. Well, we have to save it for it to give us a plot, for us to be able to plot. So let's save it in neural net 1, NN1. Okay. And then we can say plot NN1. Okay. So then it plots the neural net for us. So we have two inputs, and we did not say anything about how many neurons we want in the hidden layer. So the default is used. Default is 1. Okay. Now, how do you specify a different number of neurons? Okay. So here, right after, somewhere here, you say hidden equal to, and then you specify the number of neurons. Okay. Now let's say that we specify 2 neurons. Okay. So now if you go and plot, you see there are 2 neurons in the hidden layer. Okay. Now if you want more than one hidden layer, right? So here if you say hidden equal to 2, then that means there is only one hidden layer and we have 2 neurons there. If you want more than one, then you have to specify that as a vector. So if you say 2 comma 2, all right. So then you see there will be 2 hidden layers, okay, each with 2 layers, 2 neurons. So here if we say 2 comma 3, then the first one will have 2 nodes, first hidden layer, then the second hidden layer will have 3 neurons. Okay. So that's how you specify the number of hidden layers and the neurons. Okay. And you can specify learning rate if you want. You can specify, say, learning rate equal to 0.2, or you can just leave it out completely, which is fine too. Okay. And there is another one called linear output. Okay, the linear output is related to whether you specify an activation function or not. Okay, so if you have an activation function, it can be g of s, like what we did in the Excel. Okay, it could be logistic, could be tan h. Okay, logistic is the default, but Now, if you say linear output equal to true, so that means that activation function will not be used. But anyway, that we are getting way too technical. We don't have to worry about that. So, and this is, and you can do a plot, which we just did, and you can do weights. Okay, we really don't need to look at the weights. It doesn't. There's a kind of a black box. We are not going to be able to make any sense out of it. Now, predict will give you the prediction. Okay, so here we did not partition the data. Okay, if you had a valid data set, then you can use the predict to predict the valid the scores for the valid data set. Now, if you say NN1, predict NN1. Oh, I have to say new data, which is the same thing, tiny.df. Okay, so then it gives you prediction. Okay, what is the prediction coming out of the output node for each of the 6 observations? So we have 6 observations in the data set. For each of the 6 observations, what is the output? Okay, and you see the output is not probability. You have to be careful about that. See, there is a negative value, and there is a value that is greater than 1. So these are not probabilities. These are the output function value. Okay? So you have to be careful with that. So neural network, when you do predict, this is what it gives. So we have to take it and use it to make predictions. Okay, the actual predictions. Okay.